So before going to learn why to program, we are going to see something basic about the computer. Generally, the computer is divided into two parts, the hardware and the software. Coming to the software, it comprises of the system software and application software. So initially, we are going to see about all these things before getting into why to program. Hardware. The physical components of a computer is called as a hardware. Blindly to say, hardware is a digital machine that can understand only on and off, and it cannot make decisions of its own. So, as a programmer, you may think now, who will make them to take decisions? Let us see about that. Here comes our software. So, the software plays a vital role in commanding the hardware's what has to be done by them. So, the software will make use of the on off states of hardware effectively to make them to take decisions. So, basically, software is nothing but a set of programs that are commanding to the hardware what is to be done. So, what is a program? Program is nothing but a set of instructions written to solve a problem. These programs can be of any specific programming languages, and on the whole, it is called as a source code. And I have said as before, the computers knows only on and off. And the source code is written in some languages, either in high level language or an assembly language or some intermediate languages. So how comes the hardwares will understand these languages? So there comes the vital role of the compiler. So what is the role of this compiler is it will be translating the source code into computer understandable code, which is nothing but the machine language, that is zeros and ones, standing for on and off respectively. So this compiler will be generating the executable computer program, that is nothing called as a software. So this picture will be indicating you how the compiler is playing an intermediate role in transferring the source code to an executable code. So types of software. So normally you might have seen these types of software, that is softwares for computer games, driver softwares, educational softwares, players, media players, and operating system softwares. And on this, it is merely classified into two categories. One is system software, another one is the application software. So this picture will be indicating you how the user will be communicating to the computer hardware. The computer hardware can understand only zeros and ones. So the system software will be playing an intermediary role between the application program and the hardware, as the application program has been written in very high level languages so that the user can interact with the hardware very easily in a user friendly manner. So not only the compiler, we have three more persons involved in making our programs run. They are interpreter, linker, and loader. So initially we can see about compiler. So compiler, as we said before, it transforms the source code into a machine code, or we can also say that as an object code. And also, while it is transferring, it will be checking the syntax error and the logical error of the program. So syntax error is nothing but the mistakes what we make in the keywords of the program, as sort of spelling mistakes and also some typing mistakes. Coming to logical error, it will be checking the accurateness inside the program, which will be generating a very good output. Interpreter. Interpreter is also a program that transforms any high level language into an intermediate form. So what is the difference between this compiler and the interpreter? Interpreter interprets the source code line by line and executes it, whereas the compiler interprets as a whole source code. That is, for making use of the compiler, We have to write a whole package of a program, and for interpreter, each and every line is taken and it is being compiled. Next comes the linker. So the linker, it will be linking the object modules to form a larger program so that it can be converted into a single executable program. So this compiler is automatically invoked by the interpreter after compiling. Next, the loader. It is a very special type of program. It will be copying the program from storage device to main memory. So, what the work it does is it will be collecting all the related files from the memory to the execution part. Let us see what is a programming language. A programming language is nothing but a code which has been written in high level or intermediate code for expressing a computation that can be easily grasped by the computer, and it can be executed to do a specific task. And the programming languages, each and everything, have their own vocabulary of syntax and semantics. And these syntax and semantics helps us for instructing a computer to perform a specific task. And you might have seen a lot of examples for programming languages such as C, C++, COBOL, Python, etc. On the whole, the entire programming languages can be classified into high-level language, assembly language, and machine language. And this machine languages is comprises of zeros and ones which can be understandable by the machine. When you come to assembly languages, it may have some codes such as move, add, jump, etc. And coming to high level languages or the languages such as C, C++, in which the programming languages are similar to that of an English language. The extension of programming language classification can be extended to the fourth generation language, which is also called as the very high level language. It is a non procedural language written as in sentences. And the examples are query languages. Then comes the fifth generation language. It has visual tools and constraints which are given to the program to solve a problem. And this is the high level language, which is also called as a third generation language, assembly language, and machine language. Normally, a high level programming language is written in a general English sentence, and it is compiled and then interpreted for execution. During compilation, this high level language program, whether it is third generation, fourth generation, or fifth generation, it is converted into object code by the compiler. Classification of programming languages. Monolithic programming, the first one is nothing but the assembly language or the basic language what we have studied, and it has some global data and the codes are sequentially written. Then comes the procedural languages with the examples of Fortran and COBOL. This program is divided into subroutines with global data sharing. And then comes the structured programming, the C, Pascal, all the things are written in the structured programming languages, and it has a top-down approach with the programs broken down into modules which can be combined together to perform a specific task. Then the object-oriented programming, C++ and Java, and also there are plenty of programs available in object-oriented programming. These are task-based and data-based. Other classifications are logical oriented, rule oriented, and constraint oriented programming. So you might have got a basic idea of what all the classifications of programming and why we need to program and what is the linkage between the hardware and software. In the next session, we can see the introduction to C. Thanks.